Yeah, dear students, welcome to the Visual Analytics lecture. You know of the Corona problematic. It's not possible that we have a physical lecture where we meet in one room and discuss about all the different components, aspects, and applications of Visual Analytics. So I have to do this via a video that you can use whenever you want and wherever you want. The outline of the talk is as follows. First, I want to introduce Visual Analytics to you. So what is it about? What is part of Visual Analytics? I will also explain why Visual Analytics was invented. Yeah, what was the motivation to form a new scientific area? I want to briefly explain how it arose, what happened in the last 15 years since that time Visual Analytics is around. And I also want to explain the involved disciplines. Visual Analytics is highly interdisciplinary, many branches of computer science, but also beyond computer science contribute to Visual Analytics. Visual Analytics is about exploring, analyzing, and understanding data, large data, complex data, often time-varying data, data that is only partially reliable. Yeah, so it's quite complex, this type of data. One aspect that is important for most visual analytics solution, it's scalability. That means, does this solution also scales if we have many dimensions, many data sets, many time points? Does it scale from large output devices? Often you want to look at a laptop or a smartphone, whereas in other situations you analyze data with a large screen or even with a collection of large screens. So that all is meant with scalability. I want to describe components of visual analytics, strategies and principles that are established meanwhile, and discuss major application areas. For me, application areas is always very important for motivation. Yeah? When I was a student, I wanted to understand what is something good for. If I understand this, I'm more motivated to understand it, to deal with it. I want to start with a definition of visual analytics by Jim Thomas. Jim Thomas is a quite important figure in this area. Actually, he could be even described as the father of visual analytics. Yeah, it was mainly his initiative that visual analytics was founded. He defines it as the science of analytical reasoning facilitated by interactive visual interfaces. So it is about combining approaches from different disciplines to support the exploration of very large and heterogeneous data sets, as we have them in many areas, in business, in finance, in astronomy, in climate modeling, also in medicine, in epidemiology, for example. Visual analytics primarily supports an undirected search for trends and structures. Undirected means I do not have a clear hypothesis in mind before I start. Of course, I have some motivation to record and analyze data, but I want to find things that I cannot fully and formally describe before. I want to see trends, relations, structures, outliers, clusters. Yeah, that is what visual analytics is about. The initial focus was primarily homeland security, so actually a military focus. The US was shocked by the attacks in 2001 and they wanted to better defend their country, and they thought we should analyze and collect data about our citizens and to better understand who of them could be dangerous of making terrorist attacks. That was the initial focus. But of course, it's much broader. A short definition could also be it is an integrated combination of data analytics and interactive visual exploration. Data analytics is primarily machine learning, data mining. cluster analysis, the search for decision trees, for example, or association rules. That is data analytics, and that's quite useful. But data analytics leads to results that are hard to verify and often difficult to trust for a user. Interactive visual exploration can better generate this trust and can better enable that you really understand the data. So visual analytics is about combining both. It's not only interactive visual exploration of the data, like you see it in a weather map, for example, but it includes and integrates data analytics, like a clustering analysis. And it shows then the results, for example, of the clustering analysis. It also may show how this results depends on parameters. Yeah? Most clustering algorithms have parameters. It's interesting to see how stable the results are for different parameters. So data analytics involves pattern mining, classifiers, supervised and unsupervised learning techniques, yeah, clusterings, unsupervised, support vector machines, for example, dimension reduction, meanwhile also deep learning. Yeah? So there are also visual analytics solutions that try to overcome the black box character of deep learning solutions. Interactive visual exploration includes visual filters. What is a visual filter? An interactive facility to control which parts of the data is visible and what is not visible. That could be a couple of sliders, for example. There are multiple coordinated views. That's a bit complex. So multiple views, of course, means that I do not have only one view that presents the data, but several views that show different aspects of the data, different perspectives on the data, for example. And coordinated means that these multiple views are somehow connected with each other in the sense that if I interact in one of these views, for example, to select something or emphasize something, that is also highlighted in another view. Yeah? So there is a kind of a coordination or synchronization mechanism. Brushing and linking is a typical example for these coordinated actions. So I select something in one view and that is shown, highlighted in other views as well. Brushing is the word for this selection process and linking means the coordination with other views. Parallel coordinates is one of these information visualization techniques quite useful for high dimensional data. I would say for moderately high dimensional data, let's assume we have 10 or 12 dimensions, for example. You probably have seen about scatter plots. We will see many examples of them in the whole lecture. Scalability is an issue there. Yeah, a scatter plot is a nice idea if I only have 2 dimensions and a moderate number of data sets. What happens if I have more than 2 dimensions and more than a couple of hundred data sets? There are solutions for this. And I want to discuss glyph-based displays as another high-dimensional visualization techniques. Timelines are quite popular, kind of static visualization for time-dependent data. And there are other solutions for networked data like graphs with their nodes and edges, as well as tree maps for hierarchical structures. Integrated combination means analytics is not just a pre-process, but it is really integrated in the exploration. Before visual analytics, there was a small field called visual data mining, and that was indeed about using data mining as a pre-process and then analyzing both the data and the data mining results together, but without any means to go back to this analytic stage and ask for other types of data mining, for example. Yeah? So visual analytics means there are loops between the information visualization techniques and analytics. So here's an example, a very simple example for a scatter plot. Yeah? So it shows 2 dimensions, namely the sales of some employees and their salary. Yeah, and of course you would like to have employees that sell a lot, but their salary is not so high. Yeah, so that is shown here, and there is a relation. Yeah, the better salesperson that have higher sales in tendency also have the higher income. Employee 2 is somehow an outlier. Yeah, he has a high income, but his sales are not strong. Employee 19 is another outlier. Yeah, this guy does not earn a lot of money, actually only $20,000 per year, but he sells quite a lot. Yeah, that becomes obvious with the scatter plot display. Here you see another example, that's the famous Hertzsprung-Russell plot of visible stars. And here you see something that is actually quite typical. If you look here for a trend, then you see, well, there are several trends at the same time. Yeah? If you look at these encircled regions, you see that the correlation is different in different parts of the data. Yeah? So there are partial regressions, not global ones. Here's another example, scatter plots where we have relations, but these relations are not linear. Yeah, you see these curves that are shown here and fitted to the data. Actually, here we have a quadratic regression. And if you look carefully, you see not only a curve, but you also see a small margin around it. And that means that there is a certain uncertainty that is also computed from the data and visualized as well. So you see the regression line along with the uncertainty that is involved in the computation. So visual analytics aims at supporting analysts. Yeah, we want to use the term analyst in a quite broad term. Analysts may be in very different areas, in banking, financing, insurance companies, engineering companies, and others. Yeah? It requires an understanding of the reasoning process of these analysts. Yeah? If you want to support analysts in their reasoning process, you have to understand their reasoning process first. That means you have to understand what are the decisions that they have to take, how they make these decisions, which information is important for this, and also how common sense is used in these different areas. So therefore you need interaction techniques to explore the data. You need appropriate methods for this and parameters for fine-grained controls. And then you have to present the results in a way that is appropriate for a particular user group. There are visualization techniques like timelines, for example, yeah, where the x-axis corresponds to time. That is more or less familiar to everyone. Yeah? But there are also special types of visualization, like an age pyramid or so-called Kaplan-Meier plot. These are visualization techniques that are used in medicine. And for every physician, they are quite common and familiar. But in other areas, it makes no sense to use them because they are not familiar. Yeah? So you have to understand a little bit also the domain. In this introductory lecture, we focus more on general solutions. But if you want to apply visual analytics in practice in companies, then it also has a strong domain-specific component. For a complex reasoning process, guidance may be required. Guidance means that the user may still have a lot of flexibility, but he is supported, for example, with carefully chosen default parameters for a certain action, maybe with a certain workflow that is more or less a linear sequence of steps, analysis steps, visualization steps, where you find something, maybe you record what you have found in a structured way. Yeah? So often visual analytics systems are quite complex, and without any guidance, they are just overwhelming, and users do not get along with it. So that was what I first wanted to say about a very short introduction. I come now to a bit of the organizational stuff. With this slide, I want to inform you about who is supposed to attend this lecture. Yeah, and this is primarily the students of the computer science faculty, the master students of the computer science faculty. This is an English lecture, and therefore, of course, it addresses primarily students from data and knowledge engineering and digital engineering. The experience from last year was that the majority of the students was from data and knowledge engineering. Yeah, but of course, other master students can use this as well. Yeah, so this is a little bit more detail on how visual analytics can be used and registered for the different degree programs. Yeah, what do you have to do in addition to watching the videos that I prepare for you? You should complete the exercises. Details will be given there. You need to register for the exam approximately 4 weeks before. That will be a written exam. Yeah, the number of students typically is so high that I cannot make an oral exam. And yeah, maybe what is most important is how to download all this material, teaching material at our website, vismd.de. There is one category teaching. There you found visual analytics. And in order to get access to the slides and the videos, you need the account ESG_student and the password analytics@isg. So we have Monique, Benedikt, and Sarah who lead the exercises that will start next week, and they will inform you also about the exercise sheet. I also want to make you aware of the fact that visual analytics to some extent is an advanced lecture. It's a master lecture, and it builds primarily on visualization. Yeah? For the students in computational visualistics, there is a mandatory subject, visualization. Not everything that is discussed there is actually important for visual analytics, but some slide sets I would recommend to you to look at and at least to get a basic understanding of them. Yeah, that involves visual perception. So a lot is known about how colors are perceived, how contrasts are perceived, also how visual groupings are perceived, how a certain layout influences the perception. Basic visualization techniques are important, in particular color coding. Yeah, if you have scalar data, that is data on a scale, real world data, then often you color code them, like in the weather map. There are different color scales, they have advantages, disadvantages, and it's useful to know a little bit about this. The part that is most strongly related to visual analytics is information visualization. Yeah, there are 3 lecture sets termed information visualization 1, 2, and 3, and these are most important. You find them again at our website in the teaching category, and there is a lecture Visualisierung. It has a German name because so far it was a German lecture. And the account here to access the data is vis_student, you see it here, and vis_lecture. So the exercise primarily serves the purpose that you get some hands-on experience with data and their analysis. Some concepts from the lecture are repeated and applied to real data, often to a kind of benchmark data that's widely available. And we use primarily R as the tool for the exercises. R includes data mining and some visualization techniques that are not too bad, and also statistics. Yeah, primarily R is a statistics tool. statistics is a very established discipline in order to analyze data, and it makes a lot of sense to think of an integrated solution with statistics, data mining, and visualization. Yeah, some links. Yeah, of course, I should recommend to you something to read. And although it's a bit old, meanwhile, I still can recommend the book from Jim Thomas and Kirsten Cook, Illuminating the Path. Yeah, you you see from this title the enthusiasm of the authors for this beginning fields, the research and development agenda for visual analytics. It's freely available. Yeah, so you can download this book without any costs involved, and that is something I would recommend to you. Another book that's also freely available because it was the major result of a European research project is from Daniel Keim, Jon Kohlhammer, George Ellis and Florian Mansmann, Mastering the Information Age, Solving Problems with Visual Analytics in 2010. And I also provide a link here to a large research initiative in Germany, the Scalable Visual Analytics Priority Program. And yeah, you see the research results, the projects and publications that have been written within this Scalability Visual Analytics program at this link visualanalytics.de. This program was finished in 2016. I'm quite familiar with this program because our group was involved in all stages of this program. Why visual analytics could be a good thing and why it is not sufficient to analyze data just statistically, for example. I want to use a motivating example that probably most of my colleagues around the world would also use. It's really a famous example. It's Anscombe's quartet. It shows 4 distributions of the data. You see the raw data here, the x values and the y values. 2-dimensional scalar data, that means real valued data. And you see that the values are actually quite different. Yeah, you see this if you look a bit on the numbers, and you see this, of course, much more clearly if you look at the data in a scatter plot. You also see that in addition to the raw data presentation, there is also this line here, the regression line. That means that is the best linear fit to the data that is possible. And the first thing that may surprise you is this line is always the same. The data is so different, but the regression line, the best linear fit, is the same. And other statistics are also the same. The mean x value is the same. The mean y value is the same. The standard deviation is the same. Yeah? So with respect to their major statistical properties, these 4 distributions are the same. But actually, they are not the same. Yeah? The descriptive statistics is a kind of aggregate statistics that simplifies a lot and does not tell the full picture. Yeah? You get the full picture if you look at the data. And then you see that here, for example, you have data that is not perfectly correlated, but it follows more or less this line from bottom left to up right with some distance to the regression line. Here you see that the data is not actually linearly correlated. Yeah? That is a curve, so it may be fitted with a quadratic line. Yeah? The quadratic curve has not such a strong curvature, and therefore the regression coefficient is the same as here. Yeah? Here, on the other hand, you see that the data is perfectly correlated with the exception of this one outlier, right? That is clearly outside. And an outlier has a strong effect on a regression line because the distances to the regression line are squared. Yeah? So actually you should exclude this point and then look for the regression. Yeah? And here you have another example, yeah, where these points are very close to each other, they have exactly the same x value, and then we have here a really strong outlier. Statistically, they are the same, but in reality, they are not. So, visual analytics is about knowledge discovery. So, we may ask for a moment, how was knowledge discovered in the times when there was no visual analytics? Yeah, we could not look at large amounts of data, see trends, generate hypotheses, think about further analysis to verify these hypotheses. That is a line of thinking that is rather new. In recent time, in older times, knowledge was more acquired by interviewing experts. Experts have a lot of experience. They have seen many cases, for example, if they are physicians, and hopefully they can precisely describe their experience and their knowledge. Hopefully they remember not in a too biased manner to what they have experienced. And yeah, then a lot of knowledge may be found by interviewing different experts, seeing where they agree and where they disagree, what is common sense in their area and what is not. That is a very long process, is of course not complete, and it is by far not sure that you really derive reliable guidelines, for example. Yeah? So using data for inferring knowledge is more recent. It started, I would say, in the 1990s primarily, with yeah, a large increase in data mining and machine learning activities. Yeah? With these activities, enhanced algorithms, powerful algorithms that could analyze larger data sets in a reasonable time, also using, of course, all the progress that what was made in computing hardware, this type of knowledge discovery became possible. So the developments in computing are important here. Yeah, performance, I said already. Storage, of course, also. Yeah, if you want to analyze large data sets, at least you should be able to store them. Yeah, and there are more and more digital devices used to acquire data, sensors, digital cameras, many other um, things that are used to acquire data in a digital format so that they can be conveniently analyzed. And there is an increasing amount of data for identifying frequent patterns and correlation. This quotation is meanwhile already 9 years old. McKinsey, this large company in the US, predicted that the data scientist will be one of the most important professions in the US in the next decade. And that was true. Yeah? Still, data scientists are searched for, they are needed, they are hired, therefore, so becoming a data scientist is a good thing. A few more thoughts on why visual analytics is important and why it is important now, probably even more than 15 years before when the field was actually started and invented, one could say. Information is no more the bottleneck. At least in many areas, large amounts of data are available. Maybe not publicly available to everybody, maybe more available within a company, the data that the company has gathered and collected. Yeah, but a lot of data is available. While the availability of data increased a lot, the analytical capabilities have not increased so much. And in particular, the capabilities of our brain have not increased so much in the last 15 years. The information that is available is not perfect. Not only that it is huge and high dimensional, but it contains often a lot of redundancy. Yeah? You may acquire data with many different sensors. And if you look carefully at the data, you would notice that you can predict the values of one sensor very well by other sensors. So you do not need all the data, but somehow you have to figure out what is the important part of your data. Data in real world is almost always incomplete. Yeah, you try to follow your customers and your wishes, for example, but you never can do this for all of them for a long time. You have incomplete data. You also have inconsistent data. That means different attributes that you have acquired um, basically suggest that something is wrong in the data. Yeah, that will happen more or less frequently, but you just cannot assume that data has a perfect quality. And data is often also dynamic. That means it changes over time. And often that is the important aspect to understand how something changes over time. We now have this corona outbreak, and the question was in which parts of the world um, the numbers grow exponentially or slower or almost not at all. How this is affected spatially, yeah, countries that are closer to each other have a higher chance of influencing each other with respect to infections. So these are dynamic properties that are important. Yeah, typically you will not have the situation that the computer scientist definitely likes. We have a data dictionary that perfectly describes the data, the ranges, the dependency of the data, and everything really follows these rules. Yeah, so you often must get along with data that is not so perfect. And this is a situation where fully automatic methods typically fail. You cannot rely on them, whereas semi-automatic approaches that involve the user, steering of the user, and using his experience in interpreting data can be incorporated quite well. Yeah. So I emphasized here this word user-steered process that is guided by the user, where the user is not only in the loop, but he really decides which steps to carry out, which kinds of analysis, of visualization, of interaction, which loops of this. And among others, not only does this typically create better results compared to any fully automatic process, typically it also creates more trust in the results. Yeah, if I could influence the way that the data is analyzed and finally results occur, I know a little bit what was more reliable, what was not so reliable, where I have changed the parameters several times in a trial and error process. So that is quite important to develop trust. So visual analytics aims at exploring data under different perspectives, and it should lead to new insights. Yeah, that's the important thing. People should get new insights about the data, about trends, about patterns, relations. Yeah, if I change a certain parameter in a certain way, how this influences other parameters, other parts of my data, and finally to the generation of new hypotheses. Um, and these new hypotheses then need to be further tested. Yeah. Um, Typically in the data you can find strong correlations, but what you are actually interested in is whether there is a causal relationship. And that is something that needs further investigation. Yeah, just having a high correlation only can lead to a suspicion that there is a causal relation. So the evaluation of visual analytics systems, yeah, when you try to understand is this visual analytics system really capable and useful, such an evaluation is focused on which insights can be generated by the analysts, which hypotheses can be formed by using the system. That is much more important than the usability, for example. Yeah? If a visual analytics system does not lead experts to new insights and hypotheses, it's not important how good it could be used. Yeah? And even the performance is not so important. Yeah? I would say that has a secondary importance. If I have two visual analytics systems that I compare and they generate the same amount and quality of insights and hypotheses, then of course I would prefer the system where the analysts are faster in the sense of a better performance. Yeah? But more important is the quality in the sense of insights and hypothesis. So I provide a link here, a conversation with Jim Thomas and Pat Hanrahan about visual analytics, a video that I really can highly recommend to you. To comment a little bit on Pat Hanrahan, that is a person, yeah, that can be really attributed a pioneer in computer graphics. He worked for the Pixar company and was involved in all the computer graphic techniques necessary for computer-generated films. He was very recently awarded with the Turing Award, that is, yeah, in some sense, the Nobel Prize for computer scientists. And Pat Hanrahan, since several years, changed his working areas from supporting entertainment and films to visual analytics. So he's quite active in this area as well. Yeah, so the motivation for visual analytics is also that there are many new applications and new research questions where visual analytics as a scientific method is helpful in order to generate new information and knowledge. It is used in addition to, for example, experiments that still have a role in many areas, in the natural sciences and also in some engineering parts. But as another reasoning component, it is quite important. Yeah, so we need to acquire information with sensors, databases. I need to check the battery connection. Give me a moment. So now we have again some voltage available. Yeah, so we have sensors, databases, and the internet. Yeah, we have applications ranging from climate modeling to the healthcare system, systems biology, and disaster management. Yeah. So we have loops in the data, we have information fusion, we have simulation of data and analysis of data. We have the data mining techniques like clustering, that is an example that we will discuss much more in the next weeks, visualization and interaction. Yeah? That all is linked to each other. The acquisition of the data from databases or from the internet or from sensors, the visual analytics core systems, and application know-how. I also briefly want to discuss with you when not to use visual analytics. Visual analytics is not the solution for all problems. I would claim it is too complex for some problems. Yeah? If a problem can be solved with simpler means, it should be solved with simpler means. So for example, when the data size is moderate and the data is of high quality, yeah, it's more or less complete and reliable, then you just can visualize it, yeah, with techniques that I have presented in the visualization lecture. You give an overview of the data, you enable the user to zoom in the data, as you know it from a map, for example, yeah, zoomable interface. And then maybe you can select something, like city or something else, and you get details on demand. That means further information as a tooltip, for example. That is termed as the information visualization mantra. Overview first, zoom and filter, and then details on demand. Yeah? A couple of problems still can be solved this way. There are other problems, when they are really well defined, that can be solved by non-interactive analytical methods, such as statistics, yeah? Or optimization. Yeah? I have some, but not too many criteria, and I want to find an optimal solution that could be done with multi-objective, multi-criteria optimization. Yeah? However, most problems are not so simple. Yeah? Often the data size is larger and more complex, that the pure information visualization does not work. And also often you don't have this well-defined problem. It is not so clear what you are actually looking about. For example, in medicine, there are health surveys where a lot of data is collected, even at different parts of the country and at different time points. And the data then is analyzed to understand risk factors for certain diseases. Yeah, but the physicians do not have so many suspicious before. Yeah, they really have to detect what is important from the data. Yeah, I also want to make a remark on terminology. Terminology is a bit inconsistent in the different parts and disciplines that contribute to visual analytics. So for example, in database technology, you talk a lot about the attributes. Yeah? In data mining, you talk about the features, and that's actually the same like the attributes in databases. In statistics, the same is called variates, and in visualization, again, the same is called dimensions. Yeah? We use primarily the terminology that's used in the visualization community, which would here mean dimensions. Yeah? At some points, however, I have to explain data mining techniques that contribute to the visual analytics system, and then I will speak, for example, about a feature. Yeah? So that is a bit of a problem. Let me give a brief history of visual analytics, and you may be surprised that this brief history starts earlier than the 15 years I have mentioned several times. There were early papers on combining data analysis and visualization to evaluate data analysis techniques. So I will show an image in a minute from a paper from Ling, 1973, a computer-generated aid for cluster analysis, already in 1973. Then there are essential contributions from the statistics community where the term exploratory data analysis is used. That is really something very similar to visual analytics. They want to find things in their data that they could not formulate in advance as a hypothesis. And they use some simple visualizations for this, like the box plot, for example. Daniel Keim is a pioneer in visual analytics, and one of his famous papers from the early 1990s is VisDB, database exploration using multidimensional visualization. Yeah, Daniel Keim is a professor at Constance University, and yeah, that was also something that could be seen as a precursor of visual analytics. A colleague of Daniel Keim from the same group was Michael Ankerst, and his PhD thesis entitled Visual Data Mining was also something really important. Another PhD thesis a year later from Oliver Niggemann, Visual Data Mining of Graph-Based Data. There were workshops on visual data mining between 2001 and 2003, and essential articles by Daniel Keim as well as Heidi Schumann, the professor for visual analytics at Rostock University. Yeah? So here's an example of this early image, a computer-generated aid for cluster analysis. Data is clustered, and the results are shown here in a visualization. And basically, the result are 3 clusters, and you see that these clusters are quite well formed, namely the density of the symbols, the darkness that you perceive is different for the members of the cluster. So that tells the person who has developed this clustering that the clustering result is quite good in the sense that it summarizes things that are similar in one cluster and separates things that are not similar. Yeah? That's the whole idea about clustering. One remark on how this graphics was generated. Yeah? 1973, that was a time when you could not use your programmer graphics card as you could use it today. Yeah? So here you see alpha symmetric symbols. And these alpha symmetric symbols are overplotted several times if a large number should be shown, and they are not overplotted if a low number should be seen. So something here appears very dark, and that means that these symbols have been plotted again and again, and then it becomes dark. Yeah, it's called an alpha mosaic graphics. That was the simple type of graphic that was available at that time, but the principle would be useful today as well. Yeah, a graphical means to understand whether clustering with certain parameters um, led to a good result. So, and then there were discussions led by Jim Thomas in 2004 and 2005, first in the US, but then also quite fast in Germany. Um, Already in 2006, the first large symposium was carried out, the IEEE Symposium on Visual Analytics, Science and Technology, the VAST Symposium. It will be carried out this year for the 15th time, yeah, so that has grown and is available since then. I already mentioned this European project, Master project, where the major goal was to connect the researchers in Europe working on visual analytics solutions for very different applications. And in Germany, there was this priority program, Scalable Visual Analytics. Projects are related to text analytics, crime mapping, epidemiological data. And the project teams that worked there and were part of the overall project involved data mining, databases, human-computer interaction, and visualization as well. So these are the involved disciplines. We have mining disciplines. We have the visualization community, where primarily information visualization techniques are used, to a lower extent scientific visualization techniques, graph drawing, and rendering. At the bottom is always a rendering machine. Human-computer interaction is important. So the discipline of how to create computer-based systems in a way that users can use them easily with a low learning effort, with a high efficiency, without making too many errors. And that not only includes usability and user experience, that is a broader term that involves also that it makes fun to use a system, that it really is attractive to use it, but it also includes cooperative user interfaces. We will see this here as well, because the analysis of complex data often is so complex that 2 or even 3 users need to cooperate with their different experience and knowledge. And then there is cognition science and visual perception that takes part and is important for visual analytics. Cognition science involves decision making, for example. That is a visualization-centered view, so visualization is in the center, and then there are other disciplines that contribute: HCI, perception and cognition, data mining, spatial temporal data analysis. So often we have data that is distributed in space, which leads to visualizations that are inspired by cartography. And the data is not only distributed in space, but it also changes over time. So, and then you need an infrastructure, hardware to acquire the data, to store the data, and you need techniques to evaluate solutions. That's the outline of the whole lecture. After the introductory lecture, I want to discuss cluster analysis, show different methods. I will discuss cluster and outlier visualization. Outliers are often a side product of clustering. So everything that does not fit in a cluster is considered an outlier. That's one viable solution. But there are also specific analytical methods that detect outliers. And these are typically better, because they are really dedicated to finding outliers and not consider outliers only as a side product of clustering. There are special types of clustering, in particular for high-dimensional data, namely bi-clustering and subspace clustering. And I will discuss scatter plot-based visual representations. To say it in a nutshell, it is about scatter plot representations that work if you have a million data sets. Yeah? How can you show really a large amount of data where a conventional scatter plot would suffer strongly from overplotting? You just don't have so many pixels, and therefore there are more scalable solutions. When we have high dimensional data, we can think about reducing the number of dimensions. So that's a kind of projection, yeah. And yeah, that is an important area. We talk quite a lot about this. Also, how the user can steer dimension reduction, how he can evaluate the results, and also trigger the system to start, for example, a dimension reduction algorithm again with different parameters in order to improve the quality in a certain way. I want to discuss the visualization of association rules. Yeah? So if you analyze complex data, then you often could do this by trying to find association rules that have certain quality criteria. But typically you get dozens, millions of association rules, so there need to be some order of them. There need to be techniques to filter, to focus on important rules, and visualization is helpful for this. That is also true in a similar way for decision trees. Yeah? You can try to explain data with decision trees. That is used in some areas quite frequently. For example, physicians are used to look at decision trees. Yeah? If the patient has this or that symbol, I make this or that decision for further diagnosis. And finally, I decide on this, on that treatment. And at some point, I evaluate the treatment success, which again is a decision that leads to a further node in a decision tree. Yeah? So that is a quite useful technique to show how data is available, how data is constructed. And the question is how to visualize and interact with such decision trees. Regression models is another important topic. Yeah, and maybe at the end I discuss also a bit visual analytics in epidemiology and public health, but I guess I will not have too much time for this. I mentioned already this term scalability and want to do this again. Yeah, the scalability challenge, according to Thomas Cook. There is visual scalability, where we have the selection and parameterization of techniques to show many data sets. In the visualization lecture, I discussed this a bit in the lecture Info with 3, using literature from Stephen Ike primarily. Scalability involves display scalability. Yeah, so you may have a small monitor, a large monitor, many large monitors. Yeah, so there are solutions where you have, for example, 8 monitors, and in total you have 30 million pixels. Then of course you can display and interact with data a bit differently. Yeah, here is such a system that is used in Leitwarte is the German term, a control room for a factory, for example, where a lot of information is available and perceived and displayed for an operator who should recognize when something unusual happens so that he is able to react. So let me look for a good point when to stop this first lecture. Yeah, I want to briefly discuss an overall system for visual analytics and analytical discourse. You see that this is from the Fraunhofer Institute, EAIS, from Natalia and Gennady Angrienko. So we have raw data first. This data is transformed, that could incorporate some quality control, that could involve transforming data to another scale to make it better comparable, yeah, to a logarithmic scale, for example. So then we have raw data and transformed data, and that is used to visualize the data. And a user can perceive visual information typically quite well. He understands something, he selects some subsets he wants to analyze in more detail. He comes in this session with prior knowledge and expectations, of course, as well. And there is new knowledge that evolves over time. So the analyst extracts relevant information, links this with assumptions, with what was known before or supposed before, generates hypotheses, makes judgments, and as a consequence of all this, shown here in another cloud in a bubble, there is evolving knowledge, new knowledge that arises, that is not perfectly reliable, but a starting point for further analysis. Yeah? And this relevant information, of course, needs to be stored, made available for later use for the same analyst or for others. That's an important component of visual analytics systems, that the user is supported in organizing his findings, in storing the findings, and retrieving the findings. It's not enough that in the head of the analyst, in his brain, some clarity arises. Yeah, it is important that things are really stored, explicitly stored, and made available for later reuse. That is a simpler sketch, originally from Daniel Keim. I told you that is the German pioneer for visual analytics, and Steffen Oelze-Jafra, who worked in my group, has a little bit refined the original scheme from Daniel. So it starts with data that is transformed iteratively, maybe several times. The user may interact with the data, select subsets of the data, like it would be possible with a database query system, for example. And then the data is mapped to visualization, and it is subject to data mining. I may add data mining or statistics. And then a model arises, yeah, a data mining model that explains the data and makes predictions or classifies it. And this is integrated in the visualization, yeah, the results from data mining. That's the model visualization. The visualization also contributes to model building. Yeah? So not only that I have data mining results, I also see things in the visualization, and both together helps to find a model. Yeah? Visual reasoning is again this process of getting insights, making observations, and finally evolving knowledge. Yeah? That should be the very first part of visual analytics. Thanks for listening.